Here we go, to fix the engine of this 1978 Devil's E sports car and make it run silky smooth. Balancing is a crucial step, but balancing here isn't just about making all parts weigh the same. For an engine constantly in motion, handling this balance is a highly complex process. Today, let's follow our mechanic, using these connecting rods to see how he masters engine balancing. We know the rod's small end connects to the piston, and the big end to the crankshaft. But here's the catch. The crankshaft rotates continuously, while the piston pumps up and down inside the cylinder at high speeds. This means the rod must handle two completely different motions at once. Therefore, its mass is split into rotating mass and reciprocating mass. The rotating mass includes the big end, nuts, bolts, and bearings, because they all spin along with the crankshaft. As for the small end, it includes the piston pin, piston, and rings. They constantly move up and down with the piston, making them reciprocating mass. With two motions and two masses, we can't just weigh the rod as one solid piece. You wouldn't know its internal mass distribution. That's where this special weighing fixture comes to the rescue. Simply place the big and small ends into their designated spots. The big end rests on the scale, while the small end is suspended. This isolates and measures the weight of the big end perfectly. Using this method, the data for all 6 big ends is quickly revealed. At a glance, you can easily spot that rod number 5 has the lightest big end at exactly 522.9 grams. The difference between them is barely a few grams. To achieve perfect balance, the other 5 rods must match this lightest weight. The chamfered area here is the safest spot on the big end to shave off weight. A light touch with a handheld belt sander does the trick. After meticulous fine-tuning, every big end is perfectly matched at 522.9 grams. Following the same logic, we just flip the rod over to measure the small end's weight. Here are the final weights for the 6 small ends. Number 1 is the lightest at 177.4 grams, while number 5 tops out at 181.4. Ironically, rod 5 had the lightest big end, while rod 1 had the heaviest. This proves a vital point. Controlling only the overall weight will never result in true mechanical balance. It's as misleading as average salary statistics online. Digressions aside, balancing the small ends doesn't require shaving everything down to the absolute minimum like before. We don't have to match rod 1's 177.4 grams because we have a secret weapon, the piston's weight. Since these pistons are cast, their manufactured weights naturally vary. By weighing all 6 pistons, we can mix and match strategically. Pairing the lightest piston with the heaviest small end naturally offsets the weight difference, as mentioned earlier. The small end's reciprocating mass theoretically includes the piston pin and rings. However, these are fully machined standard parts with virtually identical weights, so we can disregard them. Our mechanic demonstrates this by showing the pins weighing exactly 120.4 grams. Here are the weights of the 6 cast pistons. The weight gap is incredibly close, with the lightest at 415.4 and the heaviest at 418.1. The variance is a mere 2.7 grams. By pairing them up complementarily, the total weight variance between each piston and small end combo shrinks drastically. Previously, the small ends had a 4-gram gap, and pistons had 2.7. After mixing and matching, the total variance drops to barely 2 grams. To perfectly balance that tiny remaining variance, we can easily shave it off the tip of the small end. Just fire up the belt sander and grind it down, but why not modify the piston itself, which clearly has rough cast edges? It's primarily because pistons are forged from aluminum alloy, which has a much lower density. To remove equal weight, you'd have to grind away a massive volume of material. Since pistons are already thin, taking unnecessary risks here is out of the question. And that wraps up our mechanic's flawless rod balancing method for this classic 1978 Devil's E engine. Honestly, His meticulous attention to every single detail is incredible. That concludes today's engine restoration journey. Thanks for watching. Before we go, a massive thank you once again for stepping into Max's restoration realm. See you next time.